Bismillahir Rahmanir Rahim. The final protocol, electronic mail. Email, as we know it. It allows us to exchange messages with one another, and it also allows us to exchange multimedia content in the form of attachments. So nowadays we can exchange images, PDF files, videos, audios, all sorts of information. So now we will look at how the email works. Email also makes use of TCP underneath. So it does need a reliable connection-oriented protocol running underneath. Now, let's look at the scenario where we have Alice and Bob, the two users. They are directly connected to the corresponding mail server, and we will now see how the transfer of information takes place. Before we get into the scenario, we need to know about the different agents. We have something called user agent. The user agent is installed on the computers of the users. And a good example would be the Outlook client. Okay, you have Microsoft Outlook, you have Eudora, different types of email clients that we have. So in this scenario, we are looking at how an email is sent and received using the user agents, right? So both sides are using a user agent, an email client. Then we have something called MTA, Message Transfer Agent. The message transfer agent is used to push the messages from one side to the other side. So you have the message transfer agent causing the interaction between the client and the server. It is mainly used for push purposes, pushing of information. And then we have the message access agent. The message access agent is used for pulling the information, right? So in this case, in our scenario, we have Alice that is connected to the network and is making use of her user agent to write an email message. When Alice wants to send this email message, an email message, not the user agent, when Alice wants to send her email, right, the MTA client will push the message from Alice to Alice's email server, right? This is the email server for Alice. So Alice, the MTA client, is now pushing the email to the server. So understand this. The interaction here is push, right? From the client to the server. Now, these messages that are to be sent, that we just received, these messages are going to sit in a queue or a spool, right? And they will be sent. Now, this is Alice's mail server, as I mentioned, but these emails are meant for other receivers who may be on other email servers. So we need to have another task of pushing the information. This time, the information is pushed from the sender's mail server to the receiver's mail server. And this is why we have another MTA client and MTA server process sitting inside the two servers, right? So the information here was a push. The information here again is being pushed whereas the information here will be pulled. Okay, we'll be pulling the information. But let's focus on the push part first. So now from the sender's mail server to the receiver's mail server, the message is now being pushed, and which is why we again have the MTA client and the MTA server processes. At the receiver, every user has been assigned a mailbox. This would be a storage space inside the server drive, which will have special space just for that user's messages. Only that user will have the right access and access permissions to that mailbox. Now, the mail servers are always on, and they're always waiting for information to come in. So when Alice wants to send something, the user agent here will send, and Alice could shut off her computer. It does not matter. But the mail server will always be on, because the mail server is waiting for clients to contact it, to send the messages. Similarly, in here, the mail server is on all the time because it is receiving the emails, and it is also waiting in case a client contacts it to retrieve their emails. So the mail now comes and sits in Bob's mailbox in the mail server. When Bob wants to access the email, Bob will enter his username and password. Now, in this case, as you know, in Outlook, we enter our username and password and we store it. So when we store our username and password, anytime we access our mail server to retrieve our email messages, we will have the user agent sending the authentication information, okay, login. Every time we contact the mail server, we need to supply the login information. Once the login information is validated, once the user is authenticated, the user can then pull the information, right? And the emails will be pulled and get stored on the user agent at the receiver side. So understand this, we have two instances of pushing the data, and we have one instance of pulling the data. And this takes place in the scenario where both Alice and Bob are making use of email clients. So this is the steps shown. So we're going from the user agent installed in Alice's computer. Using the MTA client, the email is pushed onto the MTA server. It is then stored in the queue for a short while, and the messages are then sent out. Using the MTA client again, the message is pushed to the receiver's mail server, which then stores it in its mailbox. When the receiver wants to access the email, it will contact the message access agent. After authentication, the messages will be retrieved, and through the message access agent client, they will get delivered to the destination, to the receiver. Now, why do we need to give so careful attention to the push and pull processes? It is because whenever we have the push functionality, like in this case, we have from Alice to Alice's mail server. We are pushing the email messages to the mail server for them to be sent. In this case, we make use of the SMTP protocol, simple mail transfer protocol, right? We make use of SMTP in here. Similarly, in this case, from the mail server, sending mail server, being pushed onto the receiving mail server, once again, we make use of the SMTP protocol. Whereas when we are pulling the information from the mail server to the client, we make use of POP or IMAP. So remember, SMTP is used for pushing and POP or IMAP are used for pulling the information. Now we have different commands for SMTP. For example, we have hello. Now the hello command will be used for the sender to identify itself. And then we have mail from, which will identify the sender of the message. Received to identifies the recipient of the message. Who is it going to? Data, the actual body, the text of or whatever information is there. Quit, we end the message. And we have different types of commands. Now we will look at these commands more carefully, how they are processed. And these are the different codes that we get as responses to the commands that we have given. Now let's see how the transfer of an email takes place from the client to the from the SMTP client to the SMTP server. Now, as I mentioned earlier, the SMTP server is always open because it is always expecting the client to contact it, to send something. So the client initially establishes a TCP connection with the SMTP server. When the TCP connection is established, the server will send a 220 service ready signal response back saying it is ready to accept to start the communication. The client then sends the hello message to identify itself. And the server responds with an OK saying it has received the message successfully. The client now sends something called the envelope or the introductory information about the email. In that, it will contain a message, mail from, as to who is the email from. The server sends a response, OK. Then the client sends receipt to, who is the receiver or the recipient of this message. Once again, the client sends an OK saying it has received that successfully. Then we will send the header information, which is data about the email. So in here we are sending that it is from Farazan to Firoz, dated so-and-so, and the subject is so-and-so. So the from, to fields, date field, and the subject field, this will be the data that will be located inside the header. And then we leave a blank line. We're sending a blank line. And then the actual body of the email message, the actual content. When all the text from the email is finished, a message with just a single dot is sent to the server saying this indicates the end of the email message. The server then responds back saying it has received it successfully. The client then requests a quit saying it wants to end the connection, and the server responds with 221 code with the service closed. So this is how we send an email from the SMTP client to the SMTP server. Now we will look at how the messages are pulled using POP3. Now the POP protocol is a very simple protocol, post office protocol it's called, and it is used for retrieving the messages. So the POP client, in this case we have Bob. Now Bob has sent his username, which was fine, then a password, which was fine again. So we have an authentication of the information. After which Bob now requests a list of the emails that have arrived in his mailbox inside the server. The server will respond with the email numbers and their sizes. And then Bob can ask for each email to be retrieved. So one by one, all emails will be retrieved and stored on Bob's email client, after which Bob can read those emails. So this was about POP3. Or how we receive the email messages, or how they are pulled onto the receiver. Next, we look at the MIME extension. What is the MIME extension? MIME stands for Multiple Internet Mail Extension. Multiple Internet Mail Extension, MIME. Why do we need MIME? Now the emails that are sent using the NVT 7-bit ASCII code, right? They're sent using the NVT 7-bit ASCII coding. Unfortunately, this coding does not support videos, audios, postscripts, or foreign languages. So now, how do we send that information over the email system? In this case, we make use of the MIME protocol or the MIME extension. When we have such complex information that is to be sent, which is in non-ASCII code, it goes through the MIME protocol, which converts it to the 7-bit NVT ASCII format. And it is transferred as normal over the email system. When it is received at the receiver, this information is reconverted back using the MIME extension into its original form. So we will have the video, audio, postscript format, whatever it was. And that original file is now delivered to the receiver. So this is the use of the MIME format. And in this case, if we're making use of the MIME format, we have the MIME headers, which will tell you what type of a version it is, the content, the encoding, the ID, and the description. So, for example, we have different types of data types and subtypes in MIME. We could have text, we could have multipart, which means the body is containing different data types. We have the message format being either in an encapsulated form, or it is part of a bigger message, which means it has been fragmented, or it is an external body which is a reference to another message. So this is another type of MIME. And then we have image. So we could send, so as you can see, we're sending different types of information using the MIME extension. We have text, multipart, different types of messages, images, video, audio, and applications, postscripts. So all these data types will be converted into NVT's 7-bit ASCII and transferred over the email system and then regenerated once again at the receiver. Now the next type we have is an email transfer where the sender is using the email client, but the receiver is using a web-based interface. So for example, your Google Mail, Yahoo Mail, Hotmail. So now we look at how this is taking place. So in this case, we have the sender making use of the SMTP protocol as usual to push the information. So we have SMTP client pushing to the SMTP server. Messages get spooled, queued, and then the SMTP client in the sender's server interacting with the SMTP at the receiver. The message goes and gets stored in the mailbox as usual. However, what differs here is that we are not making use of POP or IMAP to retrieve the email because we are not making use of an email client in here. We are accessing our email using the web. So we are typing HTTP, for example, yahoo.com. And we are taken to the Yahoo website where we can go and enter our login details. So this is what happens here. We enter our login details and the HTTP server that's here takes the information and sends it over to the client. So the emails that we now receive are shown on the browser. We cannot download the emails, we can only see them online. We can download attachments, but not those emails. If we want to download those emails onto our machine, we have to configure the SMTP, the POP client or IMAP client on our machines. In the third case, both the sender and the receiver of the email are using webmail. So Alice in here logs on to an email service online and sends the email. And the information is sent as an HTTP message, right? It's not an email message now. It's being sent as HTTP. And it sits at the HTTP server. But now the server takes the message and passes it on to the SMTP client, which interacts with the receiver's SMTP server. So in this case, the push operation is only taking place at the server side. Again, the received email gets stored in the mailbox, which is then when Bob logs into the HTTP server and retrieves the emails, he will see them on his browser. So in this way, we saw how we can access the email using two different ways, one using an email client and one using the web. When we make use of the email client, we make use of the SMTP and POP IMAP protocols. And when we access the emails using a web browser, we are actually making use of the HTTP protocol in this case. So this was about emails, and this brings us to an end to this chapter.